Hey guys, so I want to make a series on Influxdb, but before that I have to kind of cover the different implementations of time series databases and what a time series database is. So the difference between Influxdb, Prometheus and Timescale, although Timescale is the one in which I have the least experience. So I'm not going to cover it much. I'm just going to tell you sort of like what it is. Let me first tell you what a time series database is. So whenever you have data that you want to cluster based on time series database is really optimized for that. So for instance, if you want to say, give me all the orders for user with ID 5, that would be terrible. You don't want to do that with a time series database. A standard SQL database or a NoSQL database, they will do that just fine. But for time series database, you want to make sure that the way you want to access this data is mostly related to time. So for instance, I don't know, my CPU usage average for the last 5 minutes, or give me how much money I've sold in the last hour compared to yesterday or compared to last week. Like whenever time is the major component, how you're gonna break down your data, and then you can filter beyond that, but time is really fundamental in your query, you should be looking at time series databases. Now, I believe that right now we're seeing a spike and a tremendous growth in the use of these databases because it really is very, very useful. So I have my iPad with me. I'm going to take you through some of what I believe are the biggest differences between Influxdb and Prometheus and Timescale. And we're gonna look at what kind of use cases they cover. And in the next video, we're gonna start looking at Influxdb more in depth. So jump in with me. All right, so whenever you look at the difference between these three, you're gonna see that the major difference that is mentioned is the nature of push versus pull. You push data points to Influx, whereas Prometheus will pull you for data. What do I mean by pull you? Well, let's say you have an API, and your API has an endpoint called metrics. And in this endpoint, you say, whenever you query this endpoint, like with a get, you get something like CPU, I don't know, 50%, memory, 2 gigs of RAM. Money sold $1,000. Of course, this is not the actual format of the endpoint, but you mount an endpoint in your API that Prometheus can constantly then come and it will pull at a given point in time. And then it will store this data. And then a while later, it will come and pull again and store the data. So it's effectively sampling your metrics at different points in time. In the case of Influx, you have an API, and your API will either push data to Influx directly, or it will push data to something like Telegraf, and Telegraf will push the data to Influx. Why this difference, or when would you use Telegraf? I'll cover that later, okay? But suffice to say that this is like the major difference between the two. In Timescale, I believe you also push data. I'm gonna focus mostly on Influx versus Prometheus, and then I'm gonna compare, once that's out of the way, I'll compare that to Timescale. All right, so most videos I've watched or articles I've read, they mention this difference and they just move on, like it's no big deal. It's actually a huge deal. This will impact so much of the use cases that you can tackle with these databases. Now, which model is better is actually the wrong question to ask. The right question to ask is, which model best approaches the needs that you have for the dashboard that you're building? So let's say, for instance, let's talk about CPU. Right? I'm gonna draw a Cartesian graph, and this is time, and this is the CPU usage. Okay, so you're gonna have something like this. Your CPU is gonna spike, then it's gonna come down, then it's gonna stay calm, then it's gonna spike again. What Prometheus is gonna do is gonna come polling here. Oops, gets this point. All right, so it's gonna sample your data. There's this assumption here that there's like this continuous metric that you are sampling at different points. And then Prometheus will extrapolate and says, well, I have this point and I have this point. So it will extrapolate this increase. PromQL, which is the query language for Prometheus, makes it very easy for you to tell Prometheus exactly how you want to fill in those blanks. But you can actually also miss like this spike here if you capture this and you capture this. Of course, the faster you sample, the more precise the information gets. But you know, like I don't want to get into Shannon's theorem and things like that, but you don't want to sample too often, okay? This approach is actually beautiful for so many use cases because if you have like a lot of noise here, let's say you have a graph like this, you have like a lot of these things, and then you have up and down. You don't necessarily want to store all these super high resolution data that is gonna just take up so much space. Because Prometheus will be polling you constantly and sampling your metrics, you have this periodic data, which is amazing in the sense that you can really optimize storage. You can do so many things to really optimize querying that. If you know that you have data at periodic intervals of time, not only can you optimize storage, you can make certain assumptions about the data that you want to query. So this is great. I really like this approach that Prometheus takes, and don't get me started on the way that Prometheus handles counters, because I love that. But it's not great for every single use case. Okay, so let me move you to another one. Let's say that now we're talking about money, and let's draw this Cartesian graph. This is time, of course, and this is how much, I don't know, GMV, or how much money revenue you're making from selling, I don't know, something on an e-commerce website. Now let's say that you sold $20, then you saw a big jump of 50, then you saw 25, and then you just saw 5, and then you didn't sell anything else, just to simplify things. Prometheus is gonna scrape you maybe here and here. And Prometheus is gonna say, well, you had $20 here, you had $100 here. And so it's gonna show you an effective increase of $80 over this bucket of time. You're gonna have these two values here. That's great if that is the sort of resolution that you need. But maybe, I don't know, you're dealing with product, or you're dealing with a commercial team, and they want to know, well, actually, we made 3 sales. They're not going to see these little data points here, okay? Because Prometheus is sampling data at regular intervals. So what they're going to see is this point and this point. But because with Influx, you can push data. You could literally push 20, then you could push 50, then you could push 25, then you could push 5. Let me clean this up for a little bit. It wouldn't be periodic points that you had before. It would be a point here, then a point here, then maybe a point here, then a point here, then a point here, or something like that. It would be like irregular intervals. So when you need that, it's great, but it's not always the best because, right? It's great for money because you can really break down the money. You can know exactly when you sold how much. It's great for other kind of like business related metrics. So if you're doing business metrics, being able to have that fine control of you push exactly each data point is really helpful. Let's say you're going back to memory and you, with Influx, you push like constantly and whenever there's a change in CPU usage or something like that. That'd be crazy, right? You would have all this scattered data. In that case, you really do want that sampling. So what Influx does to work around that issue is you use telegraf. Telegraf will either sample your CPU, you install it as an agent in your instance, and it can measure things. Or you can also push a bunch of data to telegraf, and telegraf can aggregate that data. It can do certain things with that data. It can, and then push one single data point to Influx instead of pushing maybe these 4 pushes that you did. Sort of like what you would do with StatsD, for instance, if you've ever used that. That's, I think, a huge difference, the push versus polling nature. I think that with Prometheus, you have this, you're expecting this sort of like metric that is like this continuum that you're sampling. And with Influx, you can have that if you add a little bit of complexity to your setup, okay? But you can also like be pushing data to Influx. Another great thing about Prometheus are counters. So counters are numbers that are always increasing. Why? Because you have multiple approaches to counters, okay? Let's say that we're counting how many sales we make. So you make 5 sales and you push a 5. Then you reset that to 0. Then you make 10 sales and you push a 10. And then you make 2 more and you push a 2. Now let's say that you had an outage or something and you couldn't push this 5 because Influx was down or Prometheus was down. Let's say that Prometheus were a push-based system. Well, that's it. You lost this 10, right? What do? But if you're always increasing your counter, let's say that you push a 5 and then you make 10 sales and then you push 15. And then you make 2 more sales and then you push 17. All right, what happens if you lose this? that's fine because you still have that 10 here plus the 2. All right, so you missed this point, but you still have, you didn't lose the information. The difference is before you could look at it, each push and take that at face value. Now, because each push contains the data before it, you don't care about the value of the counter so much. You care about how much the counter increased. If you have this information in Prometheus, you can reconstruct this original by saying, well, I had 5 and then it increased 10 and then it increased 2. All right, but you get rid of that problem of losing a counter. So if you ever wonder why Prometheus does counters like this is exactly why. Now, all right, I'm going too far in depth with Prometheus. That's not the point of this video, but I think the pull versus push nature is a lot more fundamental than just, oh, well, how they get their data, you know. No, it has an impact in the kind of things that you can do. Now, let me cover another big difference between the two. In Prometheus, you can have only floats, whereas in Influx, you can have floats, you can have strings, you can have integers. Because you can have these different data types, you can actually do a few things with Influx that you can't do with Prometheus. Let me give you a real scenario that I had at work. One of my teams is responsible for ingesting data from our partners. So every week, our partners will send us terabytes of data, and we run a scheduled job that will ingest that data and update our databases. Okay. So it's a job that runs at a periodic time. Now think about this for a second. It's a job that starts and ends, and it's processing a file. If a job starts and ends, it means that Prometheus cannot be constantly scraping it, because it might scrape it when the job is not running. So, and then what's going to happen? And it's a different job every time, so it's not like the same job. So in order to circumvent this problem, in Prometheus you have something called a push gateway, which is like a facade that you always leave running. This is your job. It will push data to this push gateway. Prometheus will scrape this, right? So you can push and push. In my experience, this is not great. I don't like the push gateway. It doesn't aggregate metrics. So if the same job pushes two values for the same counter, only the last value will take precedence. It's complicated to use, okay? But because I can push, for instance, 4 separate metrics, but I can't push like the file name that I processed or something. So if I wanted to do something like a table, right, where I say, well, this is the file I processed. This is, for instance, how many bytes I processed in that file. This is the duration that it took for this specific file. Let's say I have t.csv. I can't sort of like create this kind of table with Prometheus with all this aggregated data for this one run, because I can't like store the file name. I can't store, for instance, if you have like an exit code, maybe it exited successfully, or maybe it gave a specific kind of error code. Like this sort of table, you can't really aggregate data like that with Prometheus. It's not meant for that. It's meant to solve a different use case. But with Influx, you can. Now, some of you might be wondering, well, but if you have to do that, then shouldn't you be using SQL, like maybe Snowflake or something like that? Like for the orders example, let's say that with Prometheus, I can track, we talked about the orders. With Prometheus, you can track, oh, I deleted that. But you can track these 2 data points for the orders with Prometheus. And if you want the accurate result, you can just go to Snowflake or your database, and you can just use Power BI or Tableau or something like that. And that's correct, right? That's true. But if you want, like, I found that with Influx, I can have a real-time information that you can query like so quickly in a matter of milliseconds, and have the breakdown of the data at the same time. So this has been great. I wish I could show the dashboards that we built for Influx for our jobs doing this kind of thing. I'll ask maybe my VP if he lets me show you like a screenshot or something. But this is another thing that you cannot do with Prometheus. So I'm not saying that Influx is better here. I'm saying they are different. They tackle different use cases. And from what I've seen so far, I feel like Influx is a superset of Prometheus. Like you could do everything you want to do with Prometheus and additional things that Prometheus can't do. Does this mean Influx is better? Well, no, it depends. Like maybe you don't have that kind of need and then you're fine with Prometheus. And because Prometheus is a cloud native foundation project, like CNCF project, it has a lot of open source support. A lot of the people working for Grafana, they work in Prometheus too, as far as I understand. Prometheus plays really nicely with Kubernetes. So if you're using Kubernetes for your deployments and for managing your cluster, Prometheus just fits right in. It can discover your services and start polling them. There's just so many great things about Prometheus. Whereas Influx is open source. Sure, the core of Influx is open source, but it's maintained by a commercial enterprise company that offers enterprise services and things like that. So you can sort of tell, like if you just open the dashboard for Prometheus and open the dashboard for Influx, and you'll tell right away. If I have to give you my opinion, completely mine, I don't know if it's right or wrong, but I feel like Influx, for a newbie, for a beginner, Influx is easier. You open the dashboard, it helps you, it walks you through how to add a data source, it walks you through how to do downsampling of your data, because that's something I haven't covered so far, but Timeseries database not only optimized for querying time, they also let you do operations on time, like aggregating, having retention policies. Like for instance, you can store high resolution data for the last week and then downsample, right? So maybe you stored each single data point, each single sale that you made, you can store for 1 week. And after 2 weeks, you just store, the counts per hour or the sum of the total of each order per hour or per minute or like whatever. You can downsample, you can have retention policies. It's really beautiful to work on time series data on a time series database. It's a completely different experience. I want to keep going, but this video is insanely long now, okay? So all I can tell you right now is that I haven't touched Timescaledb. So let me just wrap it up with that. Timescaledb is a time series database that is an add-on to your Postgres database. So if you're running Postgres, you basically install Timescale on Postgres and you can sort of expand Postgres to support time series databases. The pros is that you can use SQL to query instead of learning Flux, which is the Influxdb language, or PromQL, which is for Prometheus. You can just use SQL, you can reuse a lot of the knowledge that probably your engineers have. You can store it in one database and it will optimize storage for time series data. That's great. Actually, my first choice when I didn't know anything about time series databases was like, okay, we have a Postgres. Why don't we just add this? And that's it. The disadvantages, I think, is that is a little less efficient in terms of storage and a little slower in terms of the throughput that you can put it through. For most of my use case, actually, Timescale would have worked. The biggest problem I have, and the reason I don't have a lot of knowledge on Timescale, is that what is one of the biggest selling points? That because it's running on Postgres, you could just join it with your other tables, like your user table and your orders table, and you can like get a lot of detail and take advantage of time series all in one database. The problem is that we are using RDS, like in AWS, we're using a managed Postgres instance from AWS, and you cannot add Timescale to that. I think there's a GitHub issue for it, but I think maybe it's also a licensing issue. But if you're using RDS, you're out of luck. You have to hire a Postgres database from Timescale. Like they have a hosted solution that you can hire. But for me, for my company, it's like a lot of paperwork going through financials, and like I couldn't get it done. So we already had Influx for some of the teams, and so that's what we used. There's a lot I haven't covered here, but I hope I've covered enough for you to just know at least where to go from here. okay? And I'm gonna tell you more in upcoming videos. Everything I've told you here actually took me weeks, if not months, to learn. And I'm gonna show you about Flux in my next videos. I had to learn like from pain because I couldn't find any proper YouTube tutorial or anything that would teach me Flux, which is the Influx query language. So I am not gonna charge you for it. All I'm gonna charge you is a like. So if this video was helpful to you, if you made it this far, just leave a like, and that helps me out a lot. And subscribe, tell your friends, maybe share this. If you have team members that are evaluating time series databases, I'm gonna make a lot of content about that. So stick around, and yeah, have a great day.